Suppose you are running out of the digital pins on the microcontroller and if you want to use more of them. So what will you do in this case? Would you go for another microcontroller with more digital pins, or can you use the analog pins for digital input or output? Like in this case, I am using the push button in the digital input mode and the LED in the digital output mode, right? By connecting them to the analog pins. So in this video, I will show you how you can do the same and what does the pin mode function do in the background. So let's get started. Now the common myth about the analog pins is that most of the beginners think that analog pins are only reserved for the sensors that can read the voltages between 0 and 5 volt. But the actual reality is that on the Atmega 328P microcontroller, which this Arduino Uno is using, all the analog pins A0 to A5 are actually the digital GPIOs that have an analog to digital converter attached to them, right? So this ADC is what makes them special. And because of this ADC, we can use the analog pins as the digital pins. So you can refer this diagram for your understanding that ADC is attached to all of the analog pins A0 to A5, right? This is ADC. So you can see that the analog pins A0 is used as digital pin number 14 because here the digital pins are ending at D13, so we can use this as D14. Similarly, A1 is used as D15, D16, D17 and all the way up to D19. So in the circuit, mind that I am using the push button in the input mode and not in the input pull-up mode, right? Because my next explanation is based on this input mode itself. Now let me tell you key takeaway here that both digital and the analog pins are defined in the input mode and they remain in the floating state by default when you power on the microcontroller. So what is this floating state? Floating state also called as high impedance state. So in this state, when you are not connecting anything to the pin, it can pick up random noise from its surrounding and it may accidentally trigger your circuit, right? Now my question here is that suppose we want to use the pin in the input mode, then why do we need to define it in the input mode using this pin mode function, like as I'm doing in this circuit diagram? So to answer this question, this data direction register comes into play. So when you call this function pin mode on any pin in the input mode, what happens at the hardware level? The code writes the 0 at the corresponding bit in the DDR. So your code might not be the only thing that touches this pin. If you are using other libraries like for sensors, displays or any other communication, those libraries may also change the modes of the pin in the background, right? This pin. But you don't want that to happen. So by explicitly setting the modes of the pin using the pin mode function, you ensure your code to be deterministic. So basically this pin mode function tells the compiler that it don't care about what happened before. From this moment onwards, this pin should be remain in the whatever mode you are defining. Like if you are defining input mode, it should remain in the input mode. If you are defining output mode, it should remain in the output mode. So analog pins are just the digital pins with extra functionality. And what is the functionality? The ADC, right? So don't be afraid to use them as digital pins. And let me know in the comment section what the most creative way you have used the hidden features of the Arduino. And if you want more such videos in the future, then subscribe for more and share this video. And thanks for watching.